Yeah, good afternoon. My name is Hua. I work for Andy. Today I'm going to talk about CRCP, Mechanistic-Empirical Pavement Design. So in my presentation, I will give you some background information about the CRCP and its application in Texas. And then I will go over the current empirical design procedure. And then I will show you the development of our Texas CRCP-ME design procedure. And then show you the design software itself. At last, I will give you the comparison result between the Texas CRCP-ME design procedure and the current AASHTO 93 design. Yeah, this is a picture of CRCP. CRC stands for Continuous Reinforced Concrete Pavement. So it has long-tier steels and transverse steel. So there are no regular spaced transverse joint in CRCP. This is the concrete pavement distribution map for TxCRCP. The red is for the continuous reinforced concrete, and the blue is for the joint concrete pavement. So TxCRCP has used the CRCP since the 1950s, and then due to the excellent performance of the CRCP, we have built all the major, urban highways in CRC. Yeah, this chart shows the line mile of our 25 districts. Houston has about 6,000 line miles CRC, and total statewide we have about 14,000 line miles CRC. This chart shows you the line mile of a jointed concrete pavement. Dallas district has most jointed concrete pavement. Okay, now I will reveal the current empirical design method. The method was based on empirical data from AASHTO tests during late 50s. Most of the concrete test sections are joint pavement, not CRCP. Also, about like 1 million load application applied on those test sections. This is the design equation for AASHTO method. Basically, it's the regression relationship between the traffic load with the pavement structure capacity and also the performance. Yeah, this is the Darwin program, which is the automated program for the AASHTO 93 design procedure. So we have been using the design procedure all time, and it serves our well. And in 2004, NCHRP had released the national MPDG program, and TxCRCP started research project to evaluate the possibility to implementation, but the decision was made not to implement the national MPDG program. So in 2007, TxCRCP started our own research project to develop the ME design procedure would model the performance of a Texas concrete pavement. A 3D final element program was conducted for the CRCP performance, and also including the interaction between the longitudinal steel and the concrete. Yeah, this is the empirical design. You input the concrete material properties, the base support, and the serviceability, and then traffic. You got the design thickness. And the ME design is one step forward. You based on the concrete property, you calculate the stress strength in the concrete, and then you input the trial pavement thickness, and then you predict the performance. This is the flow chart for the ME design. Basically, after from the info you provided, the design procedure will calculate the critical concrete stress in the slab, and based on the fatigue model and also of the load applications, the damage will be calculated for each month during the design line. From the damage, and also using the transfer function, you predict the distress, which is the failure mode for CRC. Okay. So this picture, this shows the modeling part for the calculation of the concrete stress. The green elements are concrete, and then the gray are the steels, and the yellow elements are for the support layer. So the critical stress has identified along the transverse steel, not transverse, at the longitudinal steel at the transverse cracking area. So another part is to identify the failure mode for CRCP. So the punch out is the primary structural distress for CRC. In our PMIS, we have a lot of percentage of like surface spalling or the joint deterioration. Only about like 14% are real punch outs, which is the parameter we're going to use for the design. So this is the transfer function. Transfer function is the most critical part for ME design. Basically, it will link the damage with the predicted distress for CRC. So the researcher has conducted each CRC section in our PMS, which has the punch out, and then they count the real number of punch out, and then also the traffic applied, and then they develop this transfer function. Okay, now I will show you the detail of the software itself. So the software is a simple Excel worksheet. This is it has several tabs. Have the input tab, temperature, soil classification, and the concrete stress, and the plot. So in the input tab, we have a project information, design parameters, and design traffic, concrete information, and supporter information inputs. Also, several inputs are hard-coded into the spreadsheet, including the joint shrinkage of the concrete, setting temperature of concrete, months of the construction, and the code of thermal expansion value, because those values will be not known when you do the design. So this is a screenshot of the design parameter. We are using the 30 years as current design guideline, and the 10 punch out per mile is the design criteria we recommended. And on the design traffic, you input the traffic design ISO in one direction from the TPP data. And then here is different than our regular design. You need to input the trial/thickness here, and then you put the concrete property. For supporter information, you will select the natural soil classification, and then input the base type, base thickness, and the modulus of the base. And then the program will calculate the composite K. In the temperature tab has all the temperature information for each individual district each month. So for the composite K, basically is the equivalent K value for the input the subgrid type, subgrid K value, base thickness, and the base modulus. So this is the stress tab. Basically, the program will calculate the stress due to the traffic and the stress due to the environmental loading for every month, each month. And then this is the concrete stress due to the traffic loading, and this shows the concrete stress due to the environmental loading. And the program will combine those two stress into the total concrete stress. So this is the total concrete stress in this column G. From the total stress, you calculate the damage for each month, and then you accumulate the damage with the time, and use the transfer function to predict the number of punch-outs. Yeah, this is the final result. Show you predict the number of punch-outs at the end of design life. If you got the green, it means your design is adequate. If in red, it means not. You have to re-input the trail slab thickness, rerun the program until the slab thickness meet the design criteria. Yeah, this is a plot, give you the number of punch-out development with the time during the 30-year design period. And now I will go over the comparison result between the current AASHTO 93 design procedure with the new proposed ME design procedure. The researcher has conducted analysis for 6 districts like Houston, Dallas, Fort Worth, El Paso, and Waco, and the traffic level range from 1 million to 200 million design issues, and use different composite base support. So this is the table for AASHTO 93. We're just using our current design recommended input, and then the CRCP-ME design is what we are going to propose in the new pavement design line. So this chart shows the comparison result for Atlanta district. X-axis is the traffic easel, and the Y is the slab thickness. For composite base support composite KY300, the AASHTO, the new CRCP-ME program will have a little bit thicker or similar thickness compared to AASHTO 93. And then for the high K value, the TxCRCP-ME procedure will produce a little bit thinner slab thickness. Yeah, this is for Houston district, analysis result for Houston, which has a similar trend. So the conclusion we have, the new CRCP-ME method is slightly sensitive to the support condition. For K of 300, result in similar or slight thicker pavement. For the high K value, it will be at low traffic volume, the CRCP-ME will result up to 1 inch thinner section. So in summary, the TxCRCP-ME program is a simple ME worksheet, and it has been through tested and compared to our current design procedure. The implementation will including revising our current pavement design guide, obtain federal highway approval, conduct trainings. For our joint concrete pavement design, we are still using the AASHTO 93 design procedure until the new ME for CPCD developed. With that, I thank you for your attention. Yeah. So this punch out, summarize what he yeah, he's talking the original, for CRCP, you may not have the full punch out. So, but for our, I think the punch out mode here is not the like national full depth punch out. It's the middle, the middle depth, because the maximum critical stress occurred at longitudinal steel, so it's middle depth of the slab. Yeah. Yeah, so it's the right. It's not the conventional full depth puncture, but still when you're in the PMS, you record as a puncture, right?